Hi, welcome to ITC Chip. This is the second part of the Austria Microsystems AS5011 video. In the first part I said there was an easy way to read the chip. Providing this works, it's definitely the easy way to do it. There's also the hard way, which is definitely going to work. I'm not going to show you exactly how to do it because we don't have the sample chip here. But this will give you some idea of the principle involved. If the easy way doesn't work, then we can look at this more closely. Okay, we've already dealt with another chip, the Sensirion humidity and temperature sensor. I don't wonder if, being Swiss, it wasn't made by Austria Microsystems, who've done something equally strange inside this chip. So let's just have a look at its data sheet. Okay, here's the actual format. This is a chip that uses a pseudo I2C format. They have an I2C start command. But instead of having a conventional I2C start address byte at this point, they actually go straight into a command byte. So this part is like I2C, but it has no address byte. It just has a command. It also has this rather peculiar start arrangement. Again, it has the same system. Because it doesn't have an address byte, it writes data out and then data is read in. So we can see here where the chip controls the data line and where in our case the I2C to PC controls the data line. So in this case the I2C to PC writes data out and then the chip returns data to the adapter. So unlike the previous example, there's not much hope for this. Even though it has 9-bit signaling, much like an I2C bus does, it uses the start signals and the acknowledge bit and so on, we really can't use the I2C commands for it. So we're simply going to have to simulate it by bit bashing. So we've got two things available to us in our BL233 for this kind of a job, and we need to look down at SPI. In the SPI section we've got chip select and strobe pins. You can manually control all the pins, so we'll find this under direct port IO somewhere. And we can read and write 8 bits of data. So what we're going to need to do to control this chip is to bit bash some of the edges, and then 8-bit data transfers we can handle using the SPI commands, which are the Y commands here. Y puts it into the SPI mode, W writes, R reads. So we'll just go back to real term now. Here on the tab we've actually got a here's the Sensirion humidity sensor, and we can actually do something with it. Let's just clear the screen and have a look. So here you can see we send an I2C stop in this case, and we're using the Y command, writing out some data to clear the sensor. Read temperature gets to be quite a mess really. So these O commands are bit bashing commands. Here we're doing bit bashing operations on the port to set it up, set up the correct edges. At this point we're doing an 8-bit write operation using the SPI commands, set up the SPI command, do a read operation. This part's fairly complicated. We've got a delay, we've got another SPI read operation. I think these Y1s are actually writing a single bit out the SPI, so this is handling the acknowledge bit in this case. So effectively, by a combination of SPI commands and bit bashing, we're able to directly control the chip. Even though it has a pseudo I2C, we don't use any of the I2C commands really. We just bit bash and use the SPI commands. So should the initial approach fail, it's definitely possible to use this approach to control the AS5011. Thank you.